Alright guys, last week's video, or the note about it, said that we were done with chapter 9, we were starting 10. And then as I got thinking about it, I don't think we covered two-dimensional arrays. I think we skipped it to get to arrays of objects. So we're going to cover two-dimensional arrays. What is a two-dimensional array? Well, if you had a list of test scores and you were adding them up, great. That's a one-dimensional. You could do that, in Excel in a single column. But what if you were going to write a program that would sum up all the test scores of a person year by year? So in 1976 they got these test scores, in 1977 they got another series of test scores, and in 1978. So each column, is a different cluster of data. That's a two-dimensional array. So a spreadsheet is effectively a two-dimensional array. The way you declare them is very similar to a one-dimensional array. I may just make all my notes in Java. So you use a pair of braces to declare a two-dimensional array. I personally prefer to remove the package declaration, so I'm going to delete the package declaration line. And then do move class to correct folder. If you're old school and don't use NetBeans, then you don't have to worry about that, or handle it in your own fashion. Okay, so the one-dimensional array, let's do an array events. I'm just going to call it 1D. There. Now we have a one-dimensional array that's 10 items long. Except I've decided I'm going to start putting the declaration there. I just did C code there. That's why it looked alien. So that is our array declaration, and now we need to allocate it. So there. We have an array of 10 elements. So I'm getting an error there. I forgot the word new. Yes, thank you. Then if you want to iterate it through it, or, without using a for each loop, int x is equal to 0. I'm going to use I for iterator. I is less than the length of it. I could just hardcode 10. That's really bad form. So 1d.length, I++, and so on, then print it out. System.out.println. It's just going to print out all zeros. 1d subscript I. We ought to use the random class to fill it full of data to make it more interesting. I say we go ahead and do that just for our example. But first, let's demonstrate a 2D array. We're going to use a pair of braces. Now, I did use a language where you used one pair of braces and then you put commas between the braces to indicate how many dimensions you had. Not this one. So we're going to say this is a two-dimensional array. And I'm going to call it 2D. And then when I allocate it, it has to be like that.
I think we didn't go over.
You think we went over this?
We didn't. You just introduced it to us, and I think that was the next thing we were going to cover.
Okay. So that's a two-dimensional array. So let's get our random object going so that we can fill it full of interesting data, then print it out. So random RND is equal to new random. I'm going to have to add the import for it. I'm going to cheat and let Java do it, but it's java.util.random. There he is, java.util.random. Now what I feel like doing in this case is generating a random number, a pair of coordinates, and then changing the value of the array at that position. But first we have to write some code that will print it out. So for int I is equal to 0, I is less than, yeah, we did do this, 2d.length, I++,
Oh yeah, because we tried to do a...
because we used a for each loop to do it as well. And then for j is equal to 0, I'm not going to use j because it looks too much like I. X is equal to 0, so I should be using x and y. As a matter of fact, for r is equal to 0, for row, r is less than 2d dot length, r++, and then now to column, int c is equal to 0. C is less than the length of that row. So 2d square bracket r dot length. And now let's print it out. System.out.print, not print line, because we want to fill up an entire row's worth. So 2d at position r, position column. Note the syntax. That's how you specify it. Remember playing that game Battleship where you'd say A3 or whatever? A was the row and 3 was the column, or vice versa. This is our row position and this is our column position. And I'm getting an error here because I forgot to increment my counter. After we've printed out a row, we want to print out a blank line. So to go to the next line. All right, now when I do this, this should be all zeros. We're going to print out 10 zeros in a row here. Then we're going to print out 10 zeros in a row here, except this is just not 10 zeros in a row. We're just going to print out 10, one per line. And then we're going to print out a grid, 10 rows of zeros, like that. So what I'm going to demonstrate, rather than fill every value with a random piece of data, that might be fun to go back and do for those. But I'm going to make it so that if we're going to get a pair of random numbers, and if the random number is equal to 0, 0, we're going to add 1 to that value. We're going to change it to a 1. And then we're going to do the same thing, so that if you get values 3, 4, well, that's 0, 1, 2, that's row 3, column 4, 0, 1, 2, 3, 4, like that. That's going to be incremented to 1. You know, and if we do that 100 times in a row, we're going to get a lot of values. If we ran it long enough, it should fill up every number, right? Because this is linear distribution, hopefully, and hopefully somewhat even. So if we ran it 1,000,000 times, then these numbers all ought to be pretty close. But if we do it like only 30 or 40 times, it's not going to fill up the entire grid, most likely. Come back here. So let's use our random number generator just for here firstly. We're going to need a loop. Just like the other one, I could cut and paste it. What I did is I've gone back to the declaration of the one-dimensional loop for int I is equal to 0, and this was part of our homework assignment. 1d.length I++. Now let's get a random value and then assign that into our loop. Int x is equal to r&d.next int. And if I want the value to be between 1 and 10, I better make it 1 to 11 here. Let me make sure that that's the case. Nope. We're going to make it 10 but add 1 to it, because this does not include the upper bound. Let me make absolutely sure that's the case. I really thought that I had a helper that I could just hit. It's inclusive from 0, but the upper bound is exclusive, meaning it never hits it. So I'm going to go 0 to 9, but I want to add 1 to it, so it'll be 1 to 10. Now let's set that into our array. So array value 1D at the specific index we are at, I, is equal to X. And yeah, you could shorten that a little bit, right? Did we need to store it in a temporary variable? Nah. So when we run it, we should see some nice, pretty random data. Did we have to limit it to 10? No, we could make them huge values if we wanted to, change that 10 to 1,000,000 or whatever. Then we'd have 10 numbers, much larger values. So let's write some code that'll generate 2 random values between 0 and 10. And you know what would be nice, actually, is if we took our code and we encoded those 10s to be constants. And why do I say that? Because we're going to be using those values over and over, not only as limits for the for loops, and I don't mind using those, but to generate the number between 0 and 10. It'd be nice to know what the column size is and what the row size is. So we're going to do that. We're going to come up to the top, and we're going to declare. That's the wrong one. That's C#. Let's get rid of that. Up here at the top, let's just declare 2 constants. Final int max rows is equal to 10. Final int max calls is equal to 10. I guess if I was going to follow the Java convention, I would use underscores, max underscore rows. Then when I allocate my arrays, I really don't care about this one, but I'm going to fill it in. Max rows right there. So new int max rows. More importantly is when I allocate the 2D array. I'm going to come down here to our allocation of the 2-dimensional array. So 2D is equal to new int max rows followed by max calls. That way I can go back up there and change it to make it a 20 by 20 or a 4 by 4 or whatever I want. Let's do a 4 rows by 8 columns. So our first one was 4 numbers long. The next one is 4 rows long, but each row is 8 wide. Kind of cool. And the assignment we're going to have based on 2-dimensional arrays is a little bit more rigorous, but I think we have to have array lists ready to go before we can finish that assignment. So we may have to make an intermediate one. Maybe just create a 2-dimensional array full of random numbers and print them out. So let's make some random numbers. Int row, int column. Let's get 2 random values. Row is equal to integer up to max rows. We're not going to add one because 0 to 9 or whatever is just perfect, right? Yeah, why did I do that? rnd.next int up to max rows. And then the column that we're going to increment is equal to rnd.nextInt out to max calls. Then let's increment that value. 2D at position row, end index at position column, so index row, index column, plus plus. Heck, let's repeat that like 5 times. I'm just going to do something stupid and copy and paste. Nah, let's put it in a loop. So, for int repeats is equal to 0, repeats is less than, I ought to declare this 5 as a constant, repeats plus plus. This should generate 5, increments. Kind of like 5 guesses in a game of Battleship. You're naming off, and I don't know if y'all know that game. 5 different random spots on the board we're going to be incrementing. And let's print out our array again. I did it that way. I feel like doing it with for each loops now. So we're going to do it a little bit different. For every row of ints in our twoD array, for every element or value in that row of ints. Oh, I forgot something. So for every row in the twoD array, why are you giving me grief? Row is already defined. Well, fudge. So this row. Then for every V, this column. Why am I having problems? Because I just used row and column right here. How could I fix that? I could move these two. That would be a better fix. I'm going to take that int row and that int column and put them inside that for loop. Oops, didn't mean to launch that. Alrighty, so now I really can do. For every row in our twoD array, for every column in that one-dimensional array, let's print it out. System.out.print, not print line, and then twoD at that row and column. No, just print out the column value. And then write a blank line. If the other way of printing out arrays makes more sense to you, stick with it. The syntax is shorter if you do it that way, though. I'm going to delete the extraneous braces here and leave it like that. I could even get away with deleting these. No, I couldn't. Sorry, never mind. Alright, I'm going to run it now and see if our little grid has any numbers that have been bumped up. Should not all be zeros now. So we had a 10 by 10 array, and for some reason all the values that were incremented were on that row. Okay, now they're spreading out, sort of. Oh, it's because it's printing it twice. This is a before and this is an after. So I need to just put a word here, a line. System.out.println after increments. All right, that makes sense. See, we generated 5 dots, 5 pairs of coordinates, 1, 2, 3, 4, 5, and they got bumped up. And so if we generated a lot more than 5, if I went and increased this number of repeats from 5, which should be encoded as a constant, to 50, those values are going to be a lot higher. There we go, like that. Eventually I would run into some that were greater than 9, right? So I don't know if I should cap it at 9. If I was going to cap it at 9, I would put an if statement. I would check to see the value here. Or I could print them out, so that I gave more than one space per value. So I could do this. I'm back inside my int repeats is equal to 0, repeats less than 50 line, and I'm just going to check to make sure it's less than 9. If 2D at position row column is less than 9, go ahead and increment it. That way, even if I set this, to 500 repeats, I'm going to have to change 50 to 500. Then they're all maxed out. That's okay. All right, gang, so we have our two-dimensional array code. We could have just filled it up with random values, in which case it would look a lot like this. Generate a random number, store it in there, except you'd make a nested loop, right? You'd have to do it just like this. You could not use a for each loop to do nested values because for each loops do not allow you to change the contents, to kind of read only. If you change them, that's okay, but it doesn't affect the original array. So if you're going to make a 2D array and just stuff it full of random values where every element has a different random value, use a nested loop like that. So I'm going to scroll from the top of the code to the bottom in case you need a closer look. Way up here at the top, we have import java.util.random. Inside main, we declare our random object. We have two constants, max rows and max columns. We should define a third constant for the number of increments we perform. We declare our one-dimensional array. We have a for loop to fill our one-dimensional array full of data. Just add a comment here. Fill 1D array with random values. And then we have a for loop to print it out. So that's that to that. Print the 1D array out. So here, allocate our two-dimensional array. Declare and allocate. Just like that. That's two-dimensional array. Then we add a for loop to print it out. Print the 2D array with nested for loops. Just like that. If you like taking extraneous braces out, you could remove those, but you can't remove these because effectively we have two statements. If you have more than one statement, got to use braces. Okay, now here's where we iterate, creating pairs of coordinates. Should have just called it x and y. And then adding one at those coordinates, or incrementing the value, at those coordinates. So here was our for loop for this. Int repeats is equal to 0. How many coordinates do you want to generate? Get our coordinates, int row column, assign them randomly out to the maximum number of rows and maximum number of columns. Increment at that row and column, and we just tacked on some code there to cap them so they never got greater than 9. So if less than 9, increment that position. Then we printed them out again, except we printed them out with for each loops, nested for each loops. All right, I think that's about enough for that one. Go ahead and upload this to the Dropbox, and then we're going to go on and we're going to talk next for a while about lists. So the drop box for this semester anyways is the one that says September 25H. So that's the end of chapter 9. Going to 10. I downloaded it. Why don't I see it? So chapter 10, array lists. Now array lists are awesome. Usually you're going to want to avoid using arrays, and you're going to want to use array lists. There are times when array lists aren't appropriate. Two-dimensional array. Or if your code needs to step through the arrays at maximum possible speed. An array has contiguous elements in memory. However, if you're trying to use max speed, you're probably not using Java. You would write it in C++. So the array list, what it is it's a dynamic object to where you can insert, append, and remove elements. So if you have an array and you want to add an item to the array, but you've already maxed it out, you're in trouble. You have to allocate a new array, copy all the old values into it, leave space for the new element. So for example, where'd all those come from? If I did, oh yeah, these are the C++ notes, aren't they? No, they're not. Yes, they are. Okay. So if you declare an array like this, A is equal to new int, 5. And you fill them up with data. A0 is equal to 10. A1, okay, I'm going to change it from 5 to 3 because this is tedious to type. A1 is, and you don't need to type this, A1 is equal to 20. A2 is equal to 30. And then you go, wow, I really wish I could add a fourth value. Well, you're out of luck. What you would have to do is declare a new array, copy the new values, the old values into the new array, make sure that the new array had space for the new value. And it's even worse if you're trying to insert a value. So what if we needed to insert 15 into this and we needed it in order? Not only do you have to allocate a new array that's one larger, then you have to copy all those values that you need to push down into new positions just so that you could put 15 in the right place. So the disadvantages of arrays is that they are fixed in length once declared, meaning that insertions into the middle or appending or deletions are a real problem. Now when I say real problem, you could do them and you could encapsulate them in a class or a method like that and it would work. But why do that if you have a data structure that already lets you do that? Array lists are dynamic data structures. You can create an empty array list. In fact, they always are empty unless you do something special. Then append objects, delete objects from it, insert into the middle or at the beginning or whatever. So they're much more flexible. They're much easier to use. And if you grew up in the 70s before you had dynamic objects like array lists and stuff like that, you spent a lot of time writing code that manipulated arrays and you got real tired of it. And nowadays people don't have to do that. So the array list class. The array list class provides the same basic functionality that comes with the standard array. It keeps a list of data, a series of values. But it stores an ordered collection of values that allows the access to the values via an index. So they're not stored contiguously in memory, but we don't care about that as long as we know that we can pull out item number 0, item number 1, item number 2, and it'll give us the correct values. But the added functionality, and this is what's important, the array list grows and shrinks dynamically by inserting and deleting elements at any specified location. So how you create it, you have to add the import. And then you give array list, this is kind of small print. Array list, and then you give it an element type, and we haven't seen this syntax before, but you put them between angle braces, less than and greater than. And then you do new array list, less than, greater than, and then parentheses. Now let's do that ourselves. I'm going to make a new project. Close our two-dimensional array one. I'm going to delete my package statement just because, and then right click and do move class to correct folder, or left click actually. Then import java.util.arraylist. Now down here, I'm going to create an array of ints, an array list of ints. You can do it both ways. Yeah. I'm going to just call this AR for array list. Excuse me, AR for array is equal to new int 10. That's our array. Now for the array list. Array list, angle brace, int, end angle brace. Did I say ankle brace? Angle. I'm going to call this AL for array list, is equal to new array list, capital A, capital L. You can just use an empty pair of less than, greater than at that point. You could put int there too as well, but it's redundant. It already knows that you're creating an array list of ints because you declared it there, so you don't have to do that again. I'm going to remove that int word there. And then parentheses in parentheses. Now why that weird syntax? Well, why did we have to put the parentheses? Because this is actually calling a constructor. This is a class, and this is a constructor. And this is what's known as template programming, where you create a class that can be used with any object, ints, floats, doubles, whatever. And it's going to give me an error because you're not allowed to use primitive data types to declare array lists. Unlike arrays, where you can use any data type you want, we need to use the wrapper class for this, integer. So I changed that int to an integer. Once you do that, it doesn't really matter much. You can store ints in them. You don't have to convert them to integers. They get converted to integers automagically. And the developers of Java call that boxing. And then when you pull the data back out, it gets converted to an int automagically, which they called unboxing. And we don't really care. So, if we were going to add some values to our array, array element 0 is equal to 25. Array element 1 is equal to 30. And array element 2, these are just, randomly generated values, 35. Now let's add some values to our array list. AL dot add fills that in. We don't need that. 25. AL dot add 30. AL dot add 35. Now let's see what happens if we try to print them out. I'm not going to write a for loop to print our array out. I'm just going to use arrays dot. So, system.out.println array dot toString, arrays dot toString. Why did my value scroll off? And then pass in AR, because that's the name of our array. Now we don't have to use that helper class to print out the array list. System.out.println the array list, AL. I hope this works. If we have to do something special to get it to work, we'll find out. But I believe this is going to work. It does. Compare the difference. Our array was allocated out to 10 spaces, so when we print it out, we get 10 spaces. If you allocate your array out to 1,000,000 spaces, it's going to have 1,000,000 zeros in a row. So generally, you have to allocate your array to the maximum size that you're going to need. And if you don't know how many you need, that becomes a problem. You have to take a wild guess at what the largest number would be. But this one only allocates memory as you add data to it. So that's kind of cool. Remember partially filled arrays where if we had only a certain number of pieces and we hadn't completely filled the array, we had to keep track of how many we had so that we didn't accidentally process all of those? Well, we got them there. Don't have to. Don't have to keep track of how many we've added. We could find out. Let's print how many elements are in our array. Int size is equal to AL dot size. Now, don't you wish it was dot length? Just like it is for strings and arrays. It's not. It's size. The reason for that is because there are more data types, collections, than just arrays. There are also trees and other data types where the idea of a length doesn't make any sense. What is the length of a tree? Well, you're going to lay all the branches out end to ends, so it's size. That returns the number of elements. Do you care? Well, what if you were going to calculate the average? You would need the sum of those plus the size. So let's print the array a little bit more old school. For int I is equal to 0. And then from now on, I'm probably not going to use a for loop to hit the array list. Instead, I'm going to use a for each loop, and you'll see why. I is less than the size, so a subscript L dot size I plus plus. We have to get the value out, and you could do this inside the print statement, but I'm going to separate it out. Int v, or value, is equal to array list dot get at that index. Notice the difference. How would we get it out of our array? We would have to use AR square brace I. This syntax does not work in Java for an array list. It works in C++ because you can override operators and you can override the angle braces, not in Java. So that is how you get a value out of the array list if you're not using a for each loop. And then we could print it out. System.out.println value. And yes, we could have stuck this al.get right inside the print line. We did not have to store it in a temporary variable. All right, now let's do it with a for each loop. For every element, or for every value, for int value colon in the array list,
Does it have to be a wrapper, or can it be just a regular int?
it can be a regular int. The question was, does it have to be a wrapper or can it be a regular int? You see what's happening? Even though the elements in here are integers, wrapper classes, when we use the equal sign, they get, suppose, quote, unboxed, which is converted back to an int. Weird. And then up here, when we were adding 25 and 30 and 35, these are actually integer values, but they got so-called boxed to be the wrapper class integer data types. So you're allowed to use primitive data types to put data in and get them out. If it was a more complex class, if it wasn't just a wrapper class, then yes, we would have to declare our reference type. And then we just print out that value, system.out.println value.
Well, click the like
Yeah, if you do come over here and click the error, then it, not the error, the warning, it totally changes it.
I was like, what is that?
Yeah, isn't that cool?
What?
All right, there's a style of programming known as functional programming. And the idea of functional programming is you don't have any temporary variables and you never change the value. Instead, everything is a function and you're returning immutable lists. And so that's gotten really popular. Other languages support it, and then Java decided that they were going to support it. I strongly recommend that unless you're going to read up on functional programming, you don't click on that warning and convert it. I'm just going to undo that.
Okay.
For each value inside the AL list, print that value out. It's kind of just a different syntax of the for each loop. But it can look a lot worse than that. Anyways, I'm going to undo that. So if you compare them, I think you'll see that this is a far cleaner syntax. I pretty much universally just use for each loops to get things out of array lists rather than that. This works just fine. They do the same thing. The only difference is if you need to change values in the array list, you can't do it with a for each loop, just like an array. You can change the values of specific elements in the array list. AL dot set, and I want element number 1 to have the value 33 in it, right? And then if I print it out, system.out.println AL, I'll see that one of the values has been changed to 33. Right there. So it used to say 25, 30, 35, but I did AL set. This was the index number, and I set it to 33, so element 1, the second one in the list, got changed to 33. What if you want to insert into it rather than add? These adds up here are appends. Let's make little notes to ourselves. List.add appends a value. List.set sets a value at the specified index. Pardon me?
Appending is adding to the end of the list, right?
Right.
Okay.
And I kind of wish it was just dot append, but whatever. I didn't create it. So yeah, dot add is appending, and appending means putting at the end of the list. And then we can do ll.size. And these are all methods. So you'll have to put parentheses in them, and you'll have to, fill them in with the proper parameters. Return the length of the list. And now let's remove an element. AL dot remove element number 0. Now when I print the list out, it's not going to print 25, 33, 35. It's just going to print out. What's it going to print out?
It's going to print. What do you put in there?
I'm going to put, we removed element number 0, so all that are going to be left is the 33 and the 35. So if I was going to put comments, the set change value of element 1 to 33, and this is going to be remove element 0. All right. You can make array lists of objects. Remember we had our point class? If our point class was part of this project, we could do array list of point and call it point list or PL or whatever is equal to new array list, angle braces like that. Now we don't have a point class. so that's going to fail. Want to make an array list of doubles? Remember, this always has to be a reference type and not a primitive type. So dlist is equal to new array list of type doubles. And again, you don't have to specify the type here. You could if you, but you know, some version of Java long past decided that that was redundant. You didn't have to do that. All right, what have I done wrong? Oh, I spelled array list with uppercase R. I'm going to comment this one out. So a few comments. The data type used has to be a reference type, i.e. a class, rather than a primitive type. So use wrapper classes. It's okay to do this. It handles it pretty much automatically. Does all the data conversion for you. All right, we are about done with our lecture. We need some assignments for this. And as far as the exam goes, I think this is as far as I want to put. We're going to talk more about array lists, but I want to give people a chance to do homework over array lists before they take the exam. And if I keep lecturing about it for days and days, then that's not going to quite work. So we are effectively at, let's figure out what slide we're effectively at. Here's .add. Ooh, and then we just jump into something else. Java.api. Do we get back to array list? Okay, here we do. The .get. How to update it, you do set. All right, so we got up to slide 11. So here's our assignment over array lists, our first one. Write a program that allows you to enter a series of numbers. Each time a new number is entered, add it to the array list. Let the user stop the data entry by entering a -1. So instead of asking the user, how many elements do you want this? You know, that's arrays. That's old school. Instead, we're just going to let them keep timing, but if they ever enter a -1, we stop adding to it. When the data entry is done, display the contents of the list using your own for loop. Or for each. Also calculate and display the sum and the average of the elements of the list. Well, how would you do that? For every int I in my array list, you know, sum plus equals I. Right, it's that easy. And then how would you calculate the average? Average is equal to sum divided by the length of the array list. So, like that. How about that? I'm going to delete that stuff though. Alrighty. Remember, you can't store int values directly in an array list. You have to use integers. Wrapper class to declare your array list. And I say this won't work. Yeah, just like that. Instead, when I say you would either store them, I'm going to say declare. I don't know why I said store. Or make an array list of strings and convert them to ints on the fly. Strongly recommend you do that. Just store them as ints. All right. So that's the array list portion of the assignment, but we also need to do one on 2D arrays. So that's part A. Part B, two-dimensional array assignment. write a program that will ask the user the number of rows in the array for the number of columns in the array, then declare and allocate an array of ints of that size. They can just be ints, they don't have to be integers. Fill the array, iterate through every value with a nested loop with random numbers between 1 and 9. Display the 2D array appropriately as a grid, you know, not just as one long string of numbers, you know. All right, that makes sense. All right, I'll create the drop boxes for what you did today so you can upload them.
What part of the code did I miss that's giving me error messages here?
You guys want to see?
See ya.
So yeah.
Size is a method, unlike on an array, so you need parentheses after it. That top
Okay.
one.
But what about the second one?
I'll take a peek.
If it's like add or something.
I'm not sure why I waited. Why? Seemed like it was necessary though. I'm getting some students who I don't even think took Java 1 and they're in Java 2, or else they failed Java 1. I'm really curious how they got into it. Anyways. When I was typing that, I commented it out because that's how you would get it out if it was an array. But you have to use .get in order for an array list, so just comment
Okay.
that line out.
So that would be an array.
Right. You might make it to AR to indicate that it was
I
the
think
array.
I had it as an AR, but it was like, that doesn't make sense.
Yeah, well, it doesn't do anything if it's an AR because it's just an isolated statement. It's just like typing 3 on its own line, which would work. But you just didn't see me comment it out. Sorry, I went too fast.
That's okay.
See ya.